Hi everybody. Today we're doing the root test. So this doesn't get, as much fond remembrance from people sometimes as the ratio test, but in a lot of ways it's the more powerful test to use. So, how does the root test work? Well, again, we have to have a series. We're adding up the terms and all the terms are positive. Okay? Just like we saw for the comparison test, just like we saw for the ratio test. But if we have that, we could take the kth root of AK. Okay, take that limit, and if that limit exists and is L, then, well, the test works like the ratio test did. If L is less than 1, our series converges. If L is bigger than 1, our series diverges. And if L equals 1, we have to try another test. So that's nice, right? That the lights that light up to say converges or diverges or try something else, work the same way as the ratio test did. So it's really only one set of rules. The algebra, though, for the root test can be a little more complicated because we have to take the kth root of our terms. Right? This means that the algebra can be a little messy. On the other hand, it really is more powerful. Right? One reason is think about what happens with the ratio test. Suppose that half of our terms, right, were 0. We couldn't use the ratio test at all because we'd be dividing by 0 a lot of times. But you actually can take the kth root of 0. So the root test will work in cases where the ratio test can't. But the caveat is sometimes the algebra is yuckier. So here's an example that's just sort of screaming out for the root test, though, because you've got things raised to the kth power. So if I took the kth root of this, right, well, the kth root of 3 to the negative k, right, well, you remember the kth root you could write as the 1 over k power. So, of course, things cancel. You just get get 3 to the negative 1 power. And the kth root of k, of course, will just be k. So we end up with a k and a 3 to the negative 1 power, which I'll go ahead and put in the denominator. So then, super easy to take the limit, right? As k goes off to infinity, k over 3 goes to infinity, which is definitely bigger than 1. So that means our series diverges using the root test. Here's another example. So here's k squared over 2k, over 2 to the k. Okay? This would also be a good one to use the ratio test on. But let's do the root test because I really like the root test. And the root test is pretty easy here too, because I have k squared over 2 to the k. When I take the kth root, the algebra isn't too bad. In the denominator, 2 to the k, if you take the kth root, you just get 2. In the numerator, again, this was k squared, and I took the kth root. Well, if you remember back when we were doing sequences, we had all those L'Hopital rule problems. And I said there's three that you need to remember. Right? One was that 1 plus 1 over k all raised to the kth power went to e. Another was that the kth root of k, or also the kth root of just a number, went to 1. That's really cool because that's exactly what we need here, right? We have the kth root of k twice, right? The kth root of k and the kth root of k, but both of those go to 1. So this whole limit goes to a half. And of course, a half is less than 1, so my series converges by the root test. So I really like the root test. There's a lot of advantages to using the root test because there are times when it will work where the ratio test doesn't. But you have to be able to do the algebra. For example, the root test is probably not what you want to do if you have a factorial, because taking the roots of factorial isn't going to work as nicely. But when it does work, the root test is really, really cool.